Welcome to the HyperX Academy. Today's tutorial is going to cover design properties within HyperX. Design properties are fundamental elements in defining the design space for zones or joints within a project. These properties hold critical information such as material selections, geometry variables, and other sizing inputs. Think of them as analogous to property cards or section definitions used in finite element analysis. In this video, we'll explore how design properties are created, managed, and applied, as well as different types of properties available. There are three main types of design properties: panel, beam, and joint, each serving different zone types. Let's cover each in detail. A panel design property defines inputs for 2D zones made up of shell elements. Once a 2D zone is assigned a panel design property, HyperX recognizes it as a panel and organizes it accordingly in the structure tree. There are several different panel concepts available in HyperX, including plates, laminates, sandwich panels, and stiffened panels. Plates are unstiffened isotropic concepts. Laminates can be composite solid laminate concepts with options for 1, 2, or 3 stacks. Sandwich panels consist of a top and bottom face sheet separated by a core, which can be foam, honeycomb, grid, or other materials. Stiffened panels come in both open sections, like I or Z shapes, and closed sections, like hat sections. Grid stiffened panels include multiple integral stiffeners intersecting at angles, such as orthogrid and isogrid designs. And frames refer to panels with an attached frame structure. Let's take a look at a simple example. This design property defines the material and dimension range for a metal plate. It also defines the sizing methodology HyperX will use to determine the optimum thickness. It's important to note the contrast between the HyperX design property and a FEM property section, and that HyperX is defining the entire design space rather than a single material thickness. A beam property is used for 1D zones made up of bar elements. Just as with panels, assigning a beam design property to a zone tells HyperX to treat that zone as a beam. Beam concepts include both open sections, such as I or Z shapes, and closed sections, such as tubes or boxes. Each beam type has its own unique inputs, and these are captured in the beam design property form. Finally, we have joint design properties, which define connections between two zones, whether these are physically represented in the model or located along the edge between two zones. Examples of joint design properties include edge allowable, where the joint load is generalized, fastened joints, which have one or more rows of fasteners, riveted joints, which involve rivets in the connection, and bonded joints, where bonded adherens like clevis or scarf joints are used. Each of these joint types comes with its own design inputs and is essential for correctly sizing and analyzing the connections between the zones. There are two main ways to create a design property within HyperX, either through the property tree or from the design tab on the ribbon. No matter which method you choose, the process is straightforward. To create a property via the property tree, navigate to the desired design property type, such as panel, beam, or joint. Then right-click and select the concept from the list and open the design property form. In this form, you can define whether the property is for sizing or analysis and input the necessary definitions, material options, and other parameters. For composite concepts, you also have the option to define ply angle percentages, layup rules, and fabrication constraints. Let's walk through an example. In this case, we'll choose a bonded T concept. Once selected, we'll name the design property and select the modeling technique. For this case, we'll stick with smeared, and that's because this example model does not contain discretely modeled stiffeners. Then we'll select between sizing or analysis, and we'll choose sizing. And then we'll select between metal and composite. In this example, we'll choose metal. Next, we'll choose a sizing mode, and we'll select detailed sizing for this example. Then we'll define necessary dimensions. We'll select material options. Click Apply and close out the panel design property form. Notice that your new design property is available on your property tree. Assigning a design property to a zone or joint ensures the entity inherits all the necessary inputs for analysis and sizing. This can be done in several ways. Either directly from the design property form by selecting the zones or joints and clicking Assign, or by right-clicking in the property tree and choosing Assign to Visible Selection. Or by using a click and drag method where the design property is dragged over the viewport or structures tree and zones or joints are selected. Once a design has been assigned to a selection of zones, dimension overrides can be implemented to prescribe particular inputs for individual zones without changing the entire design property. In this form, each row represents a zone that has been assigned that property, and each column is an input option based on the concept. Design properties are stored and managed in the property tree, specifically in the design node. These properties are shared across multiple projects and can be saved as part of database templates, ensuring consistency and flexibility in the design process. It's important to note that one design property can be assigned to multiple zones or joints, as long as the types are consistent. For example, a 2D panel design property cannot be applied to a 1D beam zone, or vice versa. Additionally, a zone or joint can only have one design property assigned to it at any given time. If a design property needs to be deleted, it can be removed from the property tree. However, it's important to note that a design property cannot be deleted if it is still assigned to any zone or joint. You must first disassociate it from all entities before deletion. Design properties in HyperX provide an efficient way to define the design space for zones and joints, ensuring that materials, geometry, and other sizing inputs are properly assigned for analysis. Whether you're working with panels, beams, or joints, using design properties effectively can streamline your workflow and improve the consistency and accuracy of your designs. Thanks for stopping by the HyperX Academy.